Okay, so hopefully having had a chance to answer those three questions, and I apologize the last video cut out. I'm learning very quickly that I talk way too much, which most of you probably knew, but because you understood that your grade was probably directly reflected by being nice to me, I didn't say anything about that. So, looking at these three questions, okay, let's start with the first one. I just want you to draw the standing wave for the first harmonic. So this is a violin string, which means that it has to be closed on both ends. So the first harmonic, if it's closed on both ends, would just look like this. Okay, this would be the simplest wave, standing wave you can create and still produce a sound. So it would just look like basically half of a wave. Now, to calculate how long the violin string would have to be to produce this sound, if it was the fundamental frequency, we start by just using our formula for figuring out the frequency of a note that can be produced when the ends are the same. Okay. This is the fundamental frequency, so we can say that n equals 1. So what we're left with is basically the frequency of the note, which it tells us is 256 hertz, equals how fast the note is traveling through the string, 450 meters per second, divided by 2 times the length of the string, which is what we're looking for. Okay, so you got to move some stuff around, but what you find is that you actually, when you solve it, the length of the violin string would have to be 0.87 meters or about 87 centimeters. So those of you who play strings right away are probably like, that's really long for a violin. It probably is, but as I don't know the difference between violin, medium violin, violin that's a little bit larger than medium, and the big violin, I don't know which one it would be that. So now, last one is, let's talk about the second harmonic. So what I want to know is that what's the next note that I can play on the string that can actually produce a sound? Okay, so that means we're looking for the second harmonic. Now for the second harmonic, what that means is that the n would equal 2 because it's the second harmonic now. So if I put that in this formula, if you calculate it, because you know the length of the string now, you'll actually find out that the frequency is 512 hertz. What it is just basically, it's the original fundamental frequency doubled. Okay? So the frequency of the second harmonic is 512 hertz. The wavelength, if you calculated it, remember we know the relationship between wave speed, wavelength, and frequency is wave speed, V, just equals lambda times F, frequency. Okay. But what you'll find out is that actually the wavelength is just the length of the string now. It's actually gotten shorter because it's a higher frequency wave. So lambda is 0.87 meters. Okay. So we're going to practice this, and I'm going to put a web assignment and some more stuff. I'm going to put a bunch more material because this is the first time I've done online stuff. There are other people that have been doing it for a while. They might have better ways of explaining it. But this is just kind of the way we talk about with standing waves. This is why standing waves are important to us. Because with any sort of musical instrument, in order to produce a sound, you have to have a standing wave. Okay? Now, just to kind of summarize this up and wrap it up, we see this in music, and I always bring it back to music. One, because that was what we always heard in class until we were just rudely evicted from our classroom. But we see it because that's exactly how musical instruments are designed. And as we talked about earlier in the video, the idea that different musical instruments are different types. So a clarinet is open on one end, closed on the other. A flute is open on both ends. And a violin is closed on both ends. Okay? And you'll notice off on the right side, I've kind of put this little diagram of different ways to produce sound or different notes. And while I'm not saying you should become a violin player, though playing a violin is a very admirable thing to do, and I wish I could do it, the reason I include this is because what this shows is what the string looks like when you're playing different notes, okay? And what you can do to create these notes. So the lowest note, the fundamental frequency, 110 hertz, you can see right there, all it is just that big half wave, okay? And then depending on where you put your finger on the string, you can affect what the wave looks like. And you can produce different sounds based off of that, okay? So just to kind of summarize, we talked about this idea that all a standing wave is just basically a bunch of little wave pulses that are interfering just the right way that it looks like it's just bouncing up and down and not moving at all. Okay. And you can create standing waves in different settings. One of them is you have a wave where the ends are connected. Usually that's going to be in a violin or something with a string. You can have it where the waves are open. This more than likely is going to be filled with air, and air is going to be the thing that's vibrating. Or you can have it where one of the ends is closed and one of the ends is open. This is more likely going to be air as well. And more than likely, a great example of that, if unfortunately we don't get to do that lab, I'm trying my best, would have been that we actually would have played the wine glasses and created different notes based off of the amount of air that was in the glass. Okay? Then we talked about the idea of a fundamental frequency. That just means that's the lowest note that you can create whenever you're making a standing wave. We can actually calculate what notes you can make in your standing wave, so what standing waves you can produce, and the idea that it's slightly different if the ends are the same versus if the ends are different. Okay? So I appreciate y'all watching all these videos. I know there's a lot more on there than there were meant to be, but if you have questions, please send me an email. We'll keep working through this. I didn't realize 15 minutes was so short.